Our next theorem talks about the denseness of the rational numbers in the real numbers. If a and b are two real numbers with a less than b, then the open interval ab contains a rational number. Another way of saying that is, given any two different real numbers, there's a rational number between them. And that is what defines this word. Because that's true, the rational numbers are dense in the real numbers. And let's look at this, a sketch of the proof. I think I have all the algebra necessary here. A is less than b. That implies that 0 is less than 1 over b minus a. Well, that's only because this is a positive number. And it's less than capital N for some natural number in the integers. We can use theorem 021, and this is what we're using the theorem for. We're just finding a natural number that's bigger than this. Well, that implies if you take this right here, multiply both by b minus a, we get 1 is less than b minus a times capital N. I'm just going to name this or call this line with this 1 asterisk. And the next line is going to be the double asterisks. N is less than or equal to NA, which is less than N plus 1 for some N in the integers by theorem 021. We squeeze this NA between N and N plus 1, just as we proved in the previous theorem. Now take this and take this, and they imply that N plus 1 is less than or equal to capital NA plus 1. That comes from right here. Just add 1 to both sides. NA plus 1 is strictly less than NA plus N times b minus a because of this relationship. 1 is less than b minus a times n. And if you, if you multiply this out, you get capital N times b minus capital N times a. That simplifies to be just capital N times b. And that I'm labeling the 3 asterisks. Now by this one, the 3 asterisks and the 2 asterisks, we get the following. NA is less than N plus 1, that came from here. And N plus 1 is less than NB from up here. This inequality, compound inequality, divide it all by capital N and we get A less than little n plus 1 over capital N is less than B. And we're done, because this is an integer over an integer, which is an element of the rational numbers.